Hey everybody. First of all, thanks a lot for coming. It's pretty awesome to see everybody in the room talking about mobile delivery. This kind of came out of a conversation around the lack of events focused on application delivery in the mobile context. And it came together really quickly, and obviously there's interest here, so that's pretty awesome. Let's talk about automation. So automation in general, and specifically test automation, is notoriously difficult. It seems to be something that everybody wants to do or is planning to do and is not actually doing it or isn't there yet or hasn't started for whatever reason. Mobile test automation is even more complicated than traditional test automation. So quick introduction. Pawel and I, my cohort here, we started working together at Intel doing system automation. This is my appeal to authority slide, so I'm just going to tell you a little bit about like where we're coming from, so when we say something, like there's something to back it up. So we came from Intel. We did system automation on a large scale, really complex systems like cars moving around and devices. We left Intel and we started a company called AppThwack, which allowed developers of mobile applications to test those applications on real devices in the cloud. So rather than building out your own local device lab, you could test with AppThwack. And AppThwack was acquired by AWS, and there is a new service called AWS Device Farm that we now run that does pretty much what AppThwack did, but on an AWS scale, testing applications on real devices. So today we're going to talk, during the 20 minutes or so that we have, we're going to talk about the basics. So just like high level, I mentioned automation is hard. We're going to talk a little bit about why automation is hard just in general, regardless of what you're testing. Then we're going to dive into the mobile context, and we'll talk a little bit about on the code side of things. We'll talk about the execution, where you execute, how often, and so on, and then a little bit about results. So the first thing that you want to do when you're engaging automation, you're going to tackle automation, is to set expectations. And sometimes those expectations don't come from you. They come from someone else, maybe somebody above. And they're saying things like, automate everything, we're going to save time and money, we're going to shrink the QA team, right? This is not a healthy way to come at automation. These are not the goals, right? So it's important that you know what the goals are and you set clear expectations. And those clear expectations are that you're going to free up time so that you can test more, right? It's not like suddenly your test cycle shrinks, it's just you'll be able to test more and test more thoroughly than you were previously. You're not going to save money necessarily. Ideally you catch more issues, but even that is not really the goal. The goal is just make sure that you're testing more often and more. The second part is identifying the low-hanging fruit. So again, when people come to automation, it's very tempting to think up these really complex end-to-end scenarios like, I need to test my application, communicating with 100 different devices, and one of them takes a picture of a monkey and texts it to the other one. Like, just take a step back and just, what are your key flows, right? Just sign in to the application, open up the application, launch it, make that work, and build from there. Another thing to remember is that automation is a software project, and this is probably redundant to most everyone in this room, but it is important that automation is treated like a software project, and it should be done by people that know how to code. It should be given the resources that any development team would be given, and I think one important thing here is that automated code is typically as complex or more complex than the code it's testing, so it should be treated appropriately. And the last thing on the basics before we dive into the mobile specific stuff is that there's traditionally a wall, or many people think of this wall between QA and development. We're seeing a lot of that changing now, where development teams are often the ones actually doing the tests, and the QA team might even be more like a DevOps type team that's actually just maintaining the infrastructure, putting the tooling in place, and the developers are actually writing the test automation code as part of their development process. And we see that being very, very successful because, again, automation is a software project.
Okay, cool. Hi everyone. Let's dive into more specifics around mobile. So first, like Trent said, mobile automation can be very, very difficult because of different factors that do not really exist when you do regular desktop software projects. So first you have to deal with the whole landscape that there is different options for you to test emulators, there's real devices, there's also things that can run headlessly on JVM like RoboElectric that someone mentioned earlier today. And on top of that, you have to think about the underlying network conditions, things like should I test just on Wi-Fi or do I actually need a real carrier connection? And once you start thinking about the breadth of the project, only then you will see how complex actually it can be. On top of that, there's a bunch of limitations in the tools today. And to give you some examples, the early frameworks and still very popular, like everything that is on instrumentation based for Android, for example, doesn't really allow you to venture outside of the application sandbox. And people often want to include some third-party apps automation into their flow. For example, they like to go into device settings and change some things, or go to third-party app to do the logging, for example, Facebook app. While some tools allow to do this, on Android side, you automator-based stuff. If you are using something like Espresso, you can't really do this. And similarly, on iOS side, there are some limitations that are introduced by application re-signing. That's especially difficult if you start running your tests on the cloud, because once you re-sign the app, you may lose certain entitlements. That means that you, for example, cannot test things like notifications, messaging, and so on. And in general, automating everything on a device, especially a real device, can be very tough. We often hear about folks wanting to test receiving phone calls, sending text messages, snapping pictures with camera, and those things cannot be easily accomplished in-house, and maybe even more difficult if you want to farm it out. Another common theme that we see especially with people who are very new to the automation is it's very easy to put a flaky test case together with lots of hard-coded weights and stuff like that, and of course this needs to be avoided, right? And especially when you start expanding and running on more and more devices, you will see that the flaky code will behave badly and your results will actually be worthless. Simply because they're not consistent across multiple devices. Another potential pitfall is the cross-platform thing. So there are many frameworks today that hold the promise of cross-platform automation. You essentially write a single script and then you can provide abstract layers for both Android and iOS. While I personally have seen a few examples where it worked. In most cases, it's a failure. Calabash is a good example here, in which in theory you could write a single scenario that provided the business logic for the application is the same both for Android and iOS. In theory, you could make it work, but again, often this is not successful, and it kind of goes back to what Trent said about automation being a software project. You have to really treat it seriously and lay out the design before you start any coding. Yeah, another interesting thing, and the final thing on here is automation becomes much easier when you actually plan for it together with the folks who build the app and make the app more testable, right? The excellent example here is, for example, games, which are notoriously difficult to automate, especially when you talk about UI testing, because there's really no element IDs or anything like that that can be used to easily identify things on the screen. But you can bake different things into a game that will either help you discover where these elements are or help you gather additional data that can be particularly useful to game developers. And one of the common scenarios here is that you can essentially bake in a little server that can be talked to from a framework like Calabash or Appium that allows you to retrieve some non-functional data like performance stats, for example, for the app, or again, move the flow of the game forward as you capture screenshots and data. So there are a number of things here to consider when you when you start with automation. That again, you need to start thinking about this early when you start building the app.
Yeah, and I think the one thing that I'll add there is that if you're coming into test automation, and the first question you ask is, well, how do I do this within your app, right? Like ideally, you've already thought about that when you were building it the first time around, right? It does make your life a whole lot easier. And when we talk about where you can execute your tests, right, it makes sense that if your functionality has testability in mind from the beginning, it makes your life a whole lot easier, especially if you start scaling out your automation execution from your local setup, which is likely static, to a larger farm of devices. So speaking of execution of tests, so let's say you have your tests. Now, Pawel mentioned earlier, you have a lot of options here, right? There are headless JVM environments. We have emulators, which have come a long way, but they are still emulators. We have simulators on the iOS side. We have local collections of devices. We have device labs at some larger companies. Now there are device labs in the cloud like ours. So it's a pretty interesting environment where your application is in application tests are going to execute. When it comes to strategy, we'll start with from the mobile devices and work our way back, but we will talk about kind of where you should execute your tests, given all of those options. So when it comes to mobile devices, the thing to remember here is that these are really oftentimes flaky little computers, and they don't necessarily behave as expected or consistently. If you're testing against a local device or a couple devices, you might not encounter these issues, and so you might think that your test code is very robust, but the second you start scaling up that automation execution, suddenly you notice very clearly that your tests are actually not that robust, right? So there are things to remember, like some phones, the Wi-Fi is not consistent. So if you write code that assumes a Wi-Fi connection and it works locally, you execute on a low-end device that has flaky Wi-Fi, your tests actually might not work, right?
Has anyone here ever experienced a spontaneous phone reboot? Yeah, so the same thing will happen in your device lab, right, sooner or later, and will produce results that probably shouldn't be trusted, and you have to account for it. You should just assume that that's the reality, right? It's not going to be perfect.
Yeah, and another thing here is that from device to device, they're not going to, not only will they not behave the same, but you might have various different options. Even between carrier branded devices, you might encounter firmware modifications that affect the stability of the device. So in order to address this, it's important to start small. So when we say start small, test against a local emulator or simulator or a local device, just one. Get it working, then start to scale up. We oftentimes see folks run tests on all 200 devices or 100 and something devices with code that's never actually been tested at scale. So it's really, really advisable to start small and ease into it rather than just go run on 200 tests and then have to comb through failures. And nothing is more frustrating than trying to figure out from that mountain of data if these are test framework issues, if it's the environment that you're executing on, is it your actual application? Differentiating between that at scale is very difficult. So when we what do you actually test? So in the beginning, it might be easy. You will likely have a small set of tests. They're very manageable. As that grows, as your coverage grows, you'll likely have a lot of tests. So one thing is to break your tests out into logical groupings. So maybe you have regression, smoke tests, however you decide to break it down. I would advise, I think we see a lot of success where people break it into that kind of test versus like a functionality breakdown where it's like, here are my login tests, here are my other tests. So there's that. And then we see a lot of companies are now running test code like on commit. So they're actually executing tests on using commit hooks. Now you don't want to run all of your tests likely, and you don't need to run on 200 devices on every single commit. So we see a lot of success with running on a small set of devices very, very regularly. They might even be local devices. Or emulators and simulators before moving on to the local devices, so you can catch them even earlier, and then fanning that out to a larger collection of devices and a larger set of tests, maybe on a nightly build or a release build. So it's important to sort of break that down. You don't need to run everything every single time. So building a device lab. So this, I think, it's pretty much ubiquitous at this point. Like everybody has a cabinet or a desk somewhere that's full of phones, covered in phones and tablets and so on. And over time, they keep on accumulating because new devices come out. So there's some things to know when you're like building this out. So first and foremost, it's one thing to buy all the devices, and that's an ongoing thing. Making them actually robust enough to handle execution of test automation code is tough. So there are some limitations to how many devices you can have on a single server. So there are stability issues that you'll need to account for. On OS X specifically, this is especially difficult. It's actually just one device. On an instance of OS X, there are ways.
Plus limitations associated with virtualization because of the ULS stuff. So yeah, that makes it costly, not just to build, but also maintain, right? Because of the amount of hardware. And then there are also weird issues once you start building your own device lab, and we went through this more than once. You'll see things like all of these devices work fine, and then I plug in this new shiny thing to the same hub, and everything dies, right? Nothing shows up on ADB anymore, and you try to figure out, okay, so what's going on really? Like, what's the story? So if you want to build it right, it's a serious investment because like simple shortcuts as in running like off-the-shelf small USB hubs or even ditching USB hubs completely, right? I mean, needs to happen sooner or later. And then when you think about this even more serious, what about redundancy, for instance? You may notice that some devices are more flaky than others. Like Trent said, some devices may just randomly crash, possibly because of OS issues, possibly because of some services that are running on these devices that are uploaded, pre-installed by the carrier manufacturer. So you want to account for this so you can always have a device of a given type available, and that means redundancy. But even if you have multiple copies of the same hardware, how are you going to manage the execution? How are you going to you'll have to build a scheduling engine that will essentially do failover and rerun tests if device errors occurred and so on. So it quickly can become a very serious undertaking. And like Trent said, it's easy to buy cables and devices, but when you start thinking about the rest, what you're going to do with it, then it's becoming more difficult.
Right, and there are a couple tools though to make your lives easier. So Spoon is a really good solution for test automation, execution of test automation code. And there's also OpenSTF, which is a nice way to manage your devices. It doesn't support automation, but it allows you to remote in, so you can actually do some maintenance on the devices that you have locally. But again, both of these they have the same limitations when it comes to how many devices you can have hanging off a single server. So you'll still have to work around that. But it's not like there's nothing out there for you. Managing a device lab on a small scale, like a small set of devices, like 5, 10 devices, is definitely doable. You start growing that out and it starts to become exponentially more difficult. So a quick shameless plug, there are providers in the cloud that are actually providing device farms as a service. I think on the pros side, it's pretty obvious you don't have to maintain the infrastructure and devices necessary to actually have good coverage for application execution or application quality. Also on the pros side, you can run at scale more often. Everybody can use them. You're not fighting over local devices. On the cons side, there's some things to know, or things to remember, right? Your devices are not going to have, the devices in the cloud are not going to have your local configuration. They're not going to have static configurations. So for instance, if you have an active Google account, or you require, 10 different apps to be installed and each needs to be configured a certain way, you need to be aware that, you're no longer in your known, trusted local environment, you're now in the cloud. So that kind of goes back to the designing with test and automation in mind, is that when you're developing your application, you're developing your test automation code, know that you might not always be executing on servers that have your own static configuration. Your devices are not always going to be your static configuration. If you can automate it, automate it. And then you can run locally. You can plug in a new device locally, and suddenly everything will work. There's no steps there. And then you can scale out to the cloud and not have to worry about those configurations either.
Yeah, and find a few words about the results. Like I said, different issues either with device or the app itself or the framework will lead to results being really not black and white, and you need to live with it, right? So you will see failures that you won't be able to trace back to actual real failures in your app, and only seeing them repeat over time can, in many cases, only seeing them repeat over time after multiple reruns can actually give you enough data to say, yes, this is actually a problem with my app, right? And this is something that that we've seen some folks struggle with. Rather than embrace the fact that it's fuzzy, you know, they kind of reject the concept of automation as being something that makes sense whatsoever, right? And this is, of course, not the right approach, right? You get data, you just get different data than you would really like to. And you can certainly make a good use out of this data. The second, and you'll have something to add?
Yeah. One quick thing there is that it also can save you the time that you have to explain like why you're automating things, because it usually goes the blame, as soon as something fails, the blame starts with one, the tool, the framework itself, right? So if you're executing in the cloud, it's going to be like that cloud provider has a problem, right? And then once you've decided that, okay, it's not the cloud provider, it's something else, well, the next thing in line is probably the test framework that you're using. After that, it's the test code. And then finally, you might convince somebody that it's an actual issue to be addressed in the application itself, right? So that's kind of how the blame, trail of blame goes.
And it also goes back to the idea of starting small and starting simple, because if you try to dump a super complex Appium test, the risk of not getting reliable results every time is high, and most likely because of your test code is bad. So this is often the first place that you want to look at, especially if you're running on multiple devices. And then it's devices themselves, the framework. You know, the difficulty grows with the complexity of what you're trying to test. Another interesting aspect is that while most people use automation to run functional tests and are going to look for clear pass-fail results, there's a ton of other useful data that you can collect. You can run interesting non-functional tests and collect this data while your functional tests are running. So you can collect data in the background, even measuring performance of your app end-to-end as it performs transactions with your backend, report it back, and make a really good use for it for monitoring purposes, right? You could almost use your automated testing as a synthetic monitoring solution, where you run your tests periodically, not just to check the quality of the code that is pushed either to your local lab or to the cloud provider, but you can also collect data that examines the health of your entire system end-to-end. Or just capture non-functional data about the app itself. Going back to games, one of the interesting cases that we've seen recently is measuring load times. You know, apparently people do not really like to see the black screen while the game is loading, and if you have large install base on low-end devices, you want to minimize. You want to first be aware of what this time is, and then be able to minimize it. So this is one of the interesting cases that is a really low-hanging fruit and very, very important because, you know, if you mess up, if your load times are too high, you will lose revenue, right? I mean, it's very clear relation there. And again, unless you buy, you know, hundreds of devices internally, it's very easy to test it. It's very difficult to test it too. And I think that will be it, unless there are some questions.
Yeah, we have time for questions.
Yes.
We were talking about cross-platform. I know that there are cross-platform environments, cross-platform testing environments. Does this go past iOS versus AOS or Android? Does it go into, say, the Android market? Are there also cross-platform?
Sure, I will repeat the question. The question was about cross-platform, not just test frameworks, but development environments, and you know how far do they go when it comes to Android fragmentation and so on. When we discuss cross-platform, we meant primarily Android versus iOS and potentially other major platform. The idea there is essentially just like you could write a single single version of the source code and then compile it for different platforms. In theory, there's test tools that allow you to do the same, right? And to reiterate the earlier comment, I mean, unless it's done right and treated seriously, it will fail, right? Because it's not as simple as it seems. And I would even say that it's more difficult to write cross-platform tests that write cross-platform apps using tools like PhoneGap, which can be used for hybrid apps, or things like Xamarin, for example, when you actually compile the code right into the native code. Do you have anything to add? Does it answer your question more or less, or?
I don't know if you found anything like, say, Samsung versus.
Well, there are some trends probably there. I don't wanna jump ahead too much, but yeah, we collect a lot of data since we're running the cloud. So there are some trends that we see emerge when it comes to quality, common issues, and stuff like that. I cannot share any specifics at this time.
Yeah, I think when it comes to like variability between, like even within Android, right? So you have things like TouchWiz, for instance, right? And I know that the date picker, for instance, is different, even within your application, right? If you're using a time pick, date time picker, it's going to look different. So your automation strategy is going to have to be different too, right?
Or certain Samsungs having that little 3-dot widget on the home screen that can get into your UI action. So yeah, there are different things that are like device specific. Another interesting example that we've seen with Verizon devices, they have a backup. If you do not disable the backup, it will just do it every now and then, which might cause performance degradation of a device while the test is running, and you will not see it every test, and you will be scratching your head thinking like, what's going on? Like, why is it not performing consistently? And it's just other stuff that runs on the device.
I'm not sure if there are any projects out there that are like an automation abstraction, right? That would actually allow you to automate like a control or something, and then that would work cross-platform. So I don't know, maybe somebody in the room or somebody else knows of such a project, or maybe there's an opening, like an opportunity there to build something. Yeah, they're it's an onion, yeah.
The question was about some experiences building local device labs for iOS. Conceptually, it will be very similar to what you would see on Android, unless something changed. If you're using Apple tools, for example, using instruments to kick off tests on a real device, you cannot, at least that was the case in the past, you could not do this in parallel against more than one device. So if you want to build a lab at scale that allows you to run tests in parallel, you will essentially need a Mac Mini or something cheaper per device, right, in order to run these tests. And unless you want to do them, run them in serial. If you go virtualization way, I mean, you can save maybe a little bit of money because you can run Fusion, but it's, I believe, 2 instances allowed per one piece of hardware, and doesn't, what's that? Yeah, we are not lawyers, though, exactly. Don't take legal advice from me.
Or any advice?
Or any advice. Yeah, don't take any advice from me. No, but conceptually it's very, very similar. There are different tools. In the past, iOS really lagged behind when it came to additional tooling, similar to ADB. So with ADB, you can easily install apps, launch them through ADB shell, and so on. iOS lacked this. There is a project called Libal Mobile Device, which is an open source implementation of various tools like that. So you can install apps, you can see the device log, you can pull information from a device. You still cannot run any shell commands unless the device is jailbroken and you're using something like Cydia to SSH to it. But you probably don't really want to. You don't want to test on jailbroken devices, right? So there is. It's getting much better. Libal Mobile Devices is very active. One thing that is still missing from this open source toolset is ability to launch the app programmatically unless you're using something like Open URL Scheme, right? So you still need to use Xcode tooling for this. Again, unless something changed that I don't know about yet. And of course, another thing to consider is code signing. There was some talk about re-signing apps before. You know, in order to launch apps programmatically on a device, they need to be signed with developer profile because of get task allow, the flag that needs to be set to true. I might be going to too many details now. But essentially, you cannot use distribution builds or enterprise distribution builds in automation environment because you cannot really launch them programmatically and attach a debugger to them and so on. So that's why you have to resign with developer profiles, and that means a big mess with what devices are on which account and so on. So, what language are you using today for your Appium tests? You know, you just package your Java tests using Maven, and you just upload the zip with all of the dependencies to us. And assuming that there is nothing specific to your local environment in there, it should just work. We actually have a guy who wrote that package just sitting out there, so we can chat later on.
Okay. Yeah,
we can chat after.
Yeah.
Or, yeah.
Yep. Thanks everyone.